Have you ever found a jar of honey tucked away in the back of your pantry, maybe for years, and wondered, is this still good? The answer is a resounding yes. In fact, honey is one of the very few foods on this planet that essentially never spoils. It's a natural marvel, and today we're going to dive deep into the sweet science behind honey's incredible shelf life. Let's start with a mind-blowing story. Picture this: archaeologists in Egypt, carefully excavating the ancient tombs of pharaohs. These tombs, sealed for thousands of years, are like time capsules. Inside, alongside treasures and artifacts, they found something astonishing: pots of honey. We're not talking about a few hundred years old. This honey was over 3,000 years old. And the most amazing part? It was still perfectly preserved, still edible. I wouldn't recommend grabbing a spoon and digging into an ancient artifact, but scientifically speaking, it was safe to eat. This discovery wasn't a one-off fluke either. Similar finds have been made in other ancient sites, like in the country of Georgia, where archaeologists unearthed honey dating back over 5,000 years. How is this possible? What magical properties does this golden liquid possess? Well, it's not magic, it's pure chemistry, and it's a multi-layered defense system that bees have perfected over millions of years. It all boils down to three key factors: its low water content, its high acidity, and the presence of a special enzyme. First, let's talk about water. Most living things, especially the tiny microorganisms like bacteria and fungi that cause food to spoil, need water to survive and multiply. They need a moist environment to thrive. Honey, however, is what we call hygroscopic. It has an incredibly low water content, typically around 17 to 18%. This is thanks to the bees themselves. When bees collect nectar from flowers, that nectar is about 80% water. Back at the hive, the worker bees get busy. They pass the nectar from bee to bee, adding their own enzymes, and then they fan it with their wings. This process is essentially a natural dehydration system. They evaporate the water out of the nectar until it thickens into the sticky, viscous liquid we know as honey. This super low water content creates an environment that's extremely inhospitable for bacteria and mold. Any microbe that lands in honey will essentially have the water sucked right out of its cells through a process called osmosis, effectively dehydrating it to death. So no water means no spoilage. It's that simple, yet so effective. The second line of defense is honey's acidity. If you were to measure the pH of honey, you'd find it's quite acidic, typically ranging between 3.5 and 4.5 on the pH scale. To put that in perspective, that's similar to the acidity of orange juice or a tomato. This acidity is another major hurdle for any bacteria trying to set up camp. Most microbes prefer a neutral pH environment, around 7, so the acidic nature of honey acts as another powerful deterrent, preventing them from growing and spoiling the honey. Where does this acidity come from? It's created during that nectar-to-honey conversion process I mentioned earlier. An enzyme in the bee's stomachs called glucose oxidase breaks down some of the glucose in the nectar. This reaction produces two byproducts: gluconic acid and hydrogen peroxide. And that brings us to our third and perhaps most fascinating defense mechanism: hydrogen peroxide. Yes, the same stuff you might have in your first aid kit for cleaning cuts. When bees create honey, this enzyme, glucose oxidase, is mixed in. As long as the honey is sealed and undiluted, the enzyme remains mostly dormant. But if the honey gets a little bit of water in it, the enzyme kicks into gear and starts producing small, steady amounts of hydrogen peroxide. This acts as a potent antimicrobial agent, killing off any bacteria or yeast that might try to contaminate it. For thousands of years, long before we understood the science, people recognized honey's healing properties. Ancient civilizations, from the Egyptians to the Greeks and Romans, used honey as a wound dressing. They knew it helped prevent infection and sped up healing, and now we know that this slow release of hydrogen peroxide is one of the key reasons why. It's like honey has its own built-in, on-demand disinfectant system. So, to recap, we have a super concentrated sugar solution with almost no water, a highly acidic environment, and a chemical defense system that produces hydrogen peroxide. It's a triple threat that makes honey virtually indestructible when it comes to spoilage. It's a perfect storm of preservation. But there is one important caveat to all of this. For honey to last forever, it needs to be stored properly. What does that mean? It needs to be kept in a sealed, airtight container. Remember how we talked about honey being hygroscopic, meaning it has low water content? Well, that also means it's desperate to suck moisture out of the air. If you leave a jar of honey open on a humid day, it will start to absorb water from the atmosphere. If its water content rises above about 25%, some of the more resilient yeasts that can survive in honey might be able to start fermenting. This is actually how mead or honey wine is made. So, if your honey has ever gone bubbly or has a fermented yeasty smell, it means it has absorbed too much moisture. It's not necessarily harmful, but it's no longer pure, preserved honey. Another thing you might notice with old honey is crystallization. A lot of people see this and think their honey has gone bad, but that's absolutely not the case. Crystallization is a completely natural process. Honey is a supersaturated solution of two main sugars, fructose and glucose. Over time, the glucose can start to separate from the water and form tiny crystals. It just means the honey is changing its texture from a liquid to a semi-solid state. It's still perfectly safe and delicious to eat. Just place your jar of honey in a warm bowl of water, not boiling, just warm, and stir it gently until the crystals dissolve. Never microwave your honey, as the high heat can destroy its beneficial enzymes and delicate flavors. So, if your honey crystallizes, don't throw it out. It's just a sign that you have real, natural honey. In fact, some processed commercial honeys are filtered in a way that removes the pollen and other particles that can act as starting points for crystallization. So a little bit of crystallization is often a good sign. It's truly incredible when you think about it. These tiny insects have developed a food source that is not only incredibly energy-rich for them, but also has this remarkable ability to preserve itself indefinitely. It's a testament to the efficiency and elegance of nature. The next time you drizzle some honey on your toast or in your tea, take a moment to appreciate the amazing journey it took to get to your kitchen and the incredible science that allows it to last for quite literally thousands of years. Just remember to keep that lid on tight. Thanks so much for joining me on this deep dive into the world of honey. If you found this as fascinating as I did, be sure to hit that like button and subscribe for more amazing science facts. Let me know in the comments if you've ever had a super old jar of honey. See you in the next video.